Hello everybody, my name is Daniel Romero-Alvarez and I am creating this tutorial to show you how to create thresholded projections in geography using a Niche Analyst software, also called NicheA. And you can see there's a lot of lingo here, and that's because this tutorial builds on a tutorial that I also published on my website, and I will share that in a couple of seconds. So let me share my screen. And I spent a lot of time trying to make Zoom to allow me to share my desktop instead of only applications. And basically a quick solution is that you just have to install the newer version of Zoom in your computer, and that will work. So you can see here the final product of what we are going to obtain at the end, right? So this is the interface of NicheA, and you can see these white points here are the background points that we are going to create, and this convex hull here, it's what we are going to develop from the occurrence points of our species. So in order to understand that terminology better, you can come to my website, which is romerostories.com, and I published some weeks ago this tutorial on how to use NicheA. And here I am explaining the basics of the program, and there's a Spanish version and also an English version, so you can see how to create principal component analysis, how to create ellipsoids, how to import this information into the software, and the basics. So building on this tutorial is that we are creating this one, right? So when you open a NicheA at the beginning, you are going to have like this empty space. So any analysis on NicheA starts with the, starts when you upload the background points into the space. So in order to do that, you go to background data, and then we are going to create this background using a particular environmental files that I already prepared. And of course, you need to go to the previous manual in order to understand all what I said. So you go to the folder where you have your files. You go to the folder, perfect. And then here you can see EMS, and the folder has raster files, and these particular raster files are on ASCII format. So I have different folders for different files. So here, these rasters represent South America. So this is the principal component number 1 of South America, principal component number 2, and principal component number 3 of South America. And by using this option, you have to identify each file and then hit OK. Or click OK, whatever. And after that, the program will put this background cloud, which is the representation of environments in South America, right? And it's expressing this in 3 axes, X, Y, and Z. So you can see that this is the distribution of environment in South America according to these 3 principal components. So now we are going to create an ellipsoid and a convex hull based on points. These points represent localities where this particular species has been found. So in order to do that, we go to Toolbox, then Niche Simulation, and then we create N from occurrences. So we click there, and then we go to the folder where we have our points. These points are basically an arrangement of, let me see if I can show you that. So yeah, if you review which kind of object is this points object, you can go here and open with any particular text reading software. And you can see here that this object has a column with the name of the species, and 2 other columns showing longitude and latitude coordinates. And you can see that all these rows, the elements are separated by comma, and that's because this is a comma-separated file, and it has to have this arrangement in order to work. So you select that file, which is the file of the occurrences of your species. So open, and then you select the place where you are going to save that file. So we are going to put here ellipsoid 1, which is because it's going to be our species, right? So in NicheA, a trick is that you always have to enter into the particular folder and then click save. And that might be counterintuitive because whenever you're using other software, you need to actually just click the folder and then press save. But in this case, you have to enter, watch the white space, and then click save. So make sure to do that. So then, okay. And then you can see that the program is doing what it's supposed to do. So now it has finished doing that analysis, right? Creating the ellipsoid that represent the species in this particular set of environments. So now we are going to open that file. So we go to File, to Toolbox, then Niche Simulation, Open N, because we have created this. And we can select different colors at this point. This MVE means minimum volume ellipsoid, and that's the ellipsoid that was created. Convex polyhedron is the convex polyhedron that was created according to those points. And of course, the points. Usually you put the same color here for the 3 objects that you have, because sometimes you create this analysis for multiple species. And then each species is going to be represented by a color. So you go to the ellipsoid that you created, right? And then you can see that it's going to use the name of the folder. And then open again, and you can see that we have created the ellipsoid, right? So again, a lot of more detailed information on how to repeat what you are watching here can be found in the website that I said before, in the tutorial that we published in my blog. So, well, it's frozen, and that's awful. So the previous session got frozen and everything crashed after that. So here we are again. So we stopped when we already finished creating this ellipsoid, right? So then you can use the view option here in order to show different portions of what we created, right? So here, I am only showing you the points of the particular species we are looking at, right? So you can see the distribution of those points in this 3D environment that represents South America. So after that, you can see the convex hull, the convex polyhedron, and it's called here. And I am interested on this particular figure. Because as you can see, in order, this convex polyhedron, what it is doing is creating this shape that it's connecting all the points, right? But what is happening outside of those points? That's when the ellipsoid that's when the ellipsoid comes into play. So if you show the ellipsoid, right, and you basically eliminate, well, not eliminate, hide the convex polyhedron, you can see that the ellipsoid is taking into account what is happening outside the points that are defined by the convex polyhedron. But that's another kind of discussion, and potentially we can have the discussion later, or if someone is interested, whatever. So I am interested in the convex polyhedron and the points. So I turn that off. Okay, so now we are going to project this into geography. So before creating thresholded maps, we need to create the continuous output in geography. So in order to do that, we go to Toolbox, and then we go to Import Export, and then we use this Export to ENM, which stands for Ecological Niche Modeling. So we don't do that. We create, instead of doing that, we do the other one, sorry. Export N, which stands for niche as continuous raster. So we click there, and then we select the space that we are exporting, in this case, this space, right? And then we put export N as continuous raster, right? And then we can create a new folder where we are going to put this analysis. So let's put result 1. So we are going to export that analysis here. So you can see that the program is working. And now we have projected this space, this figure into geographical coordinates that can be explored in different subworlds. So for example, I have QGIS here, and we can check what we have done using QGIS. So we go to the folder, so result 1, and for some reason, okay, now it's done. So here's the file. So we can drag and drop this output into QGIS, and then we select the coordinates, and you can see the output here, right? So all the black portions are areas that are not suitable according to this particular approach, and all the shaded areas are the ones that are considered suitable, right? We are going to use this map in order to create a thresholded model. So in order to do that, we go to Toolbox, and then we go to post-ENM analysis, which means post-ecological niche modeling analysis. And then we use the threshold calculator, right? And then this window should pop up. And here we are going to put our points, the same points that we used to create the ellipsoid in the first place. So we go to points, right? And this is the CSV file that we were talking about before. And then here, select the model's result. So now we are going to put in this section the model that we just created, right? Because in order to create this threshold, what is going to happen is that we are going to put the output model and then the points there, and then the program is going to extract the values for each point according to that model output, and then it's going to decide which threshold considering these values. So that's why we need to put the model. That's why we need to create the model first. So then we go to result, right? We put the model there. And then you can also create thresholds using environmental rasters, but we are not going to do that now. So in threshold methods, you can add a method, and you have here multiple thresholding rules, but we are going to use the basic one, which is the value of the minimum training presence. And this means that once you extract the information from that model output to your points, the points are going to be ordered from the lowest from the lower to the higher value, and then it's going to use the lower value to create a threshold that transforms this model into absence below the threshold and presence above the threshold. And here is giving you the option remove 0. So you can have 0 included in your analysis or not. So in this particular, we are going to remove 0. So we hit OK, right? And then the threshold that you selected is going to appear here. And then you can go, and of course you can add multiple methods, right? You can add another method, and you can add another map. So you can do this in a batch and create information with all what you have. So then let's select another place to put this output. In this case, let's put result 2. So we save again, right? We save entering into the folder, save. And then we press OK. And then the analysis should start. And it's done actually, right? So you can see that if these windows pops up, that means that the analysis was a success. And you can see that the threshold is 0 here. So we go to our QGIS, right? And we are going to explore now this new set of results. So we come here, results 2. And then let's remove this one. And then inside the folder, you will have the occurrences with their respective value. So let me show you this. So you can see here the points, right? Longitude, latitude. So each row represents a point. And here you can see the values that were obtained from the model output that we exported before. So, so we get rid of this. And then inside the folder number 1, we can see both the continuous output of the model and also the binary output, the thresholded output. So if we paste if we drag and drop that model here to QGIS, we can see that the model has become a presence-absence a geographical notation, geographical projection, right? So in this particular case, absence is represented in white and presence is represented in black. So if we put the other model here, we can see that kind of matches what is happening, but you no longer have this grading of this shading, this grading of shades, because it's not longer a continuous map. It's a full binary projection. So you can go to single cell the color, and then you can see for some reason there's no options here, but you can put them, right? Clicking plus and then selecting a particular color for 0. So let's use white, and then a particular color for the value that you are interested on. So you saw that the value that the map is showing is 255. So you want to put 255 there. And after that, you press OK. And then you can have, you have a better visualized form of the map, right? Suitable areas on red and unsuitable areas on white. And you can do the same with the map that you have here. So you can see all the shadings, right? So you can now see here different representations of suitability, right? From the lower to the higher. And this kind of matches what we have here. Only that this time it's a binary presence absence of suitable pixels. So that's the thing. And this was the threshold calculation. Well, that was the pop-up window that we explained before. You can close this. In the output folder, you will have for sure also that information, right? If you open this threshold, you will have it here, right? The threshold value. And that's it. That's the entire tutorial. And just to let you know, again, that this is built up on this manual that we published here. There's a Spanish version and an English version. You go to romerostories.com/blog in order to find it. And let me show you, well, it's downloading the manual. You can download the manual and watch it yourself. But Niche Analyst has its own website where all these, where all its functions are clearly explained. So you can go there and explore whatever you want as well. So what I did today is based on the thresholder, in the thresholding calculator function that it's also expressed here. So let me find it. Yeah, so it's based on the threshold calculator tutorial. But I think that having a video to see what is actually happening is far more useful. And actually these kinds of videos are useful for me in the future. But if it can help anybody out there, I am super happy. So that's it. Thank you very much for watching this video. And hopefully I will do more videos in the future. It's kind of fun. Thank you very much. Bye.